the C programming language second edition. We got started with chapter 1 and today we'll be looking at section 1.2. Oh, the color is different. Section 1.2 is variables and arithmetic expressions. The next program we are going to look at uses the formula for conversion between Celsius to Fahrenheit given by Celsius temperature is equal to 5 by 9 of Fahrenheit temperature subtracted with 32. This is the equation we are going to use to convert Fahrenheit to Celsius. We need a table of Fahrenheit temperature 0 to 300 with increments of 20 to give us an output of Celsius temperatures. The program itself still consists of definition of a single function named main. We all know that our program execution begins at main, so it still contains one single function main. It is longer than the one that printed hello world, but not complicated. It introduces several new ideas including comments. Then we need declarations. We have variables, declaration of variables. We have arithmetic expressions. We have loops to do something repeatedly, and we also have output which is formatted. Formatted output means that the output you are going to print contains some formatting. So will begin our program with the usual standard inclusion of the header file standard input output. Then we need to include comment. Now what is a comment? Comment is something that explains what a particular statement or a program does. Here we'll be including a comment saying we are going to print the Fahrenheit scale to centigrade scale table where Fahrenheit goes from 0 20 in increments of 20. We go from 0 to 300 and we need such a table. So the output should be a table which contains Fahrenheit and Celsius scales where Fahrenheit is 0 to 300. This is the output that we need now. But then this particular statement it is called as a comment. This is a comment which in this case explains briefly what the program does. Any characters enclosed between star, slash and slash star are ignored by the compiler. They may be used freely to make a program easier to understand. Comments may appear anywhere a blank or a tab or a new line can. So what they're trying to tell is this particular says to the compiler that anything enclosed between these two characters is a comment and it will be ignored by the compiler. What it can be used is it can be used by the programmer to tell or describe what this particular statement does. And it can appear anywhere a blank new line or a tab space can appear, which means that after include, we usually write the line main, and we usually write the function call main after hash include. But then here, since after hash include, we could have there is a enter, which is a new line character, or there is also a blank space or a tab. Anywhere it can appear where these white spaces can appear. So going back to the program, we have written our main function, which is necessary for any C program, and the compilation begins at this stage. We'll be enclosing the set of statements inside curly brace. The first in C, all variables must be declared before they are used, usually at the beginning of the function before any executable statements. A declaration announces the properties of the variables. It consists of a type name and a list of variables. So it consists of a type name and then will be data type, and then we write the variable name. This is called as declaration of variable. Notice that we could have written int Fahrenheit, Celsius, comma, upper, comma, lower, comma, step, all in the same line. But then again, this is a good programming practice to group the variables which are going to be used together or have a similar meaning. Here, the upper, lower, and step denotes the numbers 0 to 3, 20, 40, 60, and till 300. And the Fahrenheit are the final output table, which is to be printed. So we are grouping these variables together. The type integer int means the variables listed are integers. So the type int here means the variables are of type integer. By contrast with float, so we can also have float, which are floating point numbers that may have a fractional part. The range of both integer and float depends on the machine you're using. 16-bit ints means the numbers lie between 32 minus 32,768 to plus 32,767. How we arrived at this number is insert 2 power 16 gives us 32,678, 2 power 15, and in a 16-bit number, the most significant bit holds the sign of the number. The remaining 15 bits holds the value. And this minus 32,767 768 to 0, including the 0, the maximum value we can denote in positive scale as the 67 and not 768. That is why we get this range. And these are common, as are 32-bit ends. A float number is typically a 32-bit quantity with at least 6 significant digits and magnitude generally between 10 power minus 38 and 10 power plus 38. C provides several other basic data types besides int and float, including character. So we have already seen int, float. C also provides other data types. Character is the next. Character is a single byte. Short is a short integer. Long is a long integer. And double is a double precision floating point. The sizes of all these objects are also mesh independent. There are also arrays, structures, and unions of these basic types, pointers to them, and functions that return them, all of which we will meet in due course. Then we need to write the computation aspect parts. We'll be writing, we'll be assigning. And we are going to start our Fahrenheit. We are going to start our Fahrenheit here with the value 0. So we also need to initialize our Fahrenheit to that value. So one thing to note here is that we could have as well written Fahrenheit equal to 0 and start our computation in a loop for every 20 to 0 to 300. We are going to use the formula, but then this is good programming practice to use variables so that even if we are going to change 0 or 300 anywhere, we can still update it once in the beginning of the program and we don't need to update it anywhere else. Computation in the temperature conversion begins with the assignment statements which set the variables to their initial values. Individual statements are terminated by semicolons. We need to observe that all the statements are ending with semicolon. Each line of the table is computed the same way, so we use a loop that repeats once per output line. This is the purpose of while loop. So next what we need to do is we need to write the output table, and we only have one formula to calculate the output table. Since the formula is not going to change for each value of Fahrenheit and Celsius, we are going to put it in a loop. We are writing the condition. We are enclosing the set of statements in a curly braces which need to be repeated. We need to print each time the values are printed or computed. We'll explain these things later. We have already encountered the new line character, and we also know that in a printf statement we have already encountered the argument between double quotes. We also have two more arguments in this particular function call, and then we also need to increment Fahrenheit every time by after the computation by 20. So we are using this statement. We are ending it with a semicolon. We are enclosing the set of statements with again with a curly brace, and then we are since we the functionality for what we wrote the program ends, we are ending the main statement, main function. The while loop operates as follows. The condition in the parenthesis is tested for every loop. This is the first step of execution. If true, if it is true, if the Fahrenheit is less than or equal to the upper, then the body of the loop, the three statements enclosed in it, are executed. These statements are executed next, and again it goes back to the first statement of this condition. Then the condition is retested, and if true, the body is executed again. When the test becomes false, when the Fahrenheit exceeds upper, the loop ends. The execution continues at the statement that follows the loop. So once this condition is false, once we reach the upper 300 value, once this executed, the statements after this set of statements will get executed. But then since there is nothing else here, There are no further statements in this program, so it terminates. The body of a while loop can be one or more statements enclosed in braces, as in the temperature converter, or a single statement without braces. So here we have three statements, and these are enclosed within curly braces. But if we have only a single statement after a while loop, we don't need the curly braces. Instead, what we can write is this statement without the curly brace. And why we are indenting is we can as well write as less than 10, I equal to I plus 2. This statement is perfectly fine. We are not ending the while statement with a semicolon because it is a set of statements and not a statement in itself, but then we are ending the next upcoming statement with a semicolon. So we could have written it this way in a single line since we don't need to include it in curly braces, but it is a good practice to write it below the while loop, and it is good practice to show the indent so that people would understand that it is a part of while loop statement and not a general statement. In either case, we will always indent the statements controlled by the while by either one tab stop, which we have shown as four spaces, so we can see at a glance which statements are inside the loop. The indentation emphasizes the logical structure of the program. Although C compilers do not care about how program looks, proper indentation and spacing are critical in making programs easy for people to read. We recommend writing only one single statement per line and using blanks around operators to clarify grouping. The position of braces is less important, although people hold passionate beliefs. We have chosen one of the several popular styles. Pick a style that suits you, then use it consistently. So some people try to write the position of the braces this way. Some people write the braces this way. But then what is more important is you pick a style which suits you and you stick to it consistently. Most of the work gets done here in the body of the loop. The Celsius temperature is computed and assigned to the variable Celsius by the statement shown below, shown in 1a. The reason for multiplying by 5 and then dividing by 9 instead of just multiplying by 5 by 9 is that in C, as in many other languages, integer division truncates. Any fractional part is discarded. Since 5 and 9 are integers, 5 by 9 would be truncated to 0, and so all the Celsius temperatures would be reported as 0. So what we need to observe here is that the actual formula for conversion is 5 by 9 and 2. So while writing in a C program, why we can't this way? We can write it this way. The compiler does not throw an error. But what they are trying to explain is 4 divided by 2 for a human is 2, for a computer integer computation also it is true. But then 5 by 2 for a human is 2.5. But integer calculation in a computer it shows 2 with reminder. This part of the answer is not shown in the result. It is you rather have to get it manually by writing 5 modulus operator 2, which gives us the answer 1. So since we only get the quotient part of the answer, if we write 5 by 9, it is 0 with the remainder 5. Though syntactically there is nothing wrong with our statement, it is a semantic error where we won't be getting the value which we are looking for. Instead, 5 by 9 gives us 0, and for every time the loop runs, 5 by 9 would give us 0, and hence degree Celsius would be equal to 0 degree every time this loop runs. Hence we are not going to do that. We first multiply by 5 and then divide by 9. This example also shows a bit more of how printf works. Printf is a general purpose output formatting function which we will describe in detail in chapter 7. Its first argument is a string of characters to be printed with each percentage sign indicating where one of the other second, third, and etc. arguments is to be substituted and in what form it is to be printed. So we have our printf statement. So it is a general purpose output statement. The first argument is always a set of character string to be printed. The arguments that follow is is going to tell us where it is, what to be printed, where there is a percentage character sign, how many ever percentages character signs are there, it goes and sits there. And this particular, whatever we have written here, the percentage d here says that it is going to print an integer. Again, percentage d is going to print an integer. Fahrenheit goes and gets printed there. Celsius gets printed here. This is a tab escape sequence. This is a new line escape sequence. New line we are printing because we are going to print as a table. We need new line after each printf. Tab is to just show that we are giving a space in between. Each percentage construction in the first argument of the printf. The first argument of the printf here is the one enclosed within double quotes. Each of the percentage sign construction is paired up with the corresponding second argument, third argument, etc. They must match up properly by number and type or you'll get wrong answers. So let us say the first argument in our printf statement, which is enclosed within double quotes, has 5 percentage t constructions. So we need 4 other arguments to printf, and we also need all the 4 of them to be integers. If it doesn't match, it will throw an error. By the way, printf is not part of the C language. There is no input or output defined in C itself. Printf is just a useful function from the standard library of functions that are normally accessible to C. The behavior of printf is defined in the ANSI standard, however, so its properties should be the same with any compiler and library that conforms to the standard. In order to concentrate on C itself, we won't talk much about input and output until chapter 7. In particular, we will defer formatted input until then. If you have to input numbers, read the discussion of the function scanf in section 7.4. Scanf is like printf except that it reads input instead of writing output. There are a couple of problems with the temperature conversion program. The simpler one is that the output isn't very pretty because the numbers are not write justified. So when we run this particular program, we get the output as why we get this way is that we are using a tab space after our Celsius and Fahrenheit, but then it is no, this is a right justified number. We usually write it this way, but then if without right justification, the output will get as with a tab space we'll get minus 17, with a tab space we'll get minus 6. So this doesn't look very pretty. We need to format the output. There are a couple of problems. That's easy to fix, the right justification. If we argument each percentage %d in the printf statement with a width, the numbers printed will be right justified in their fields. For example, what we can write is to print the first number of each line in the field of 3 digits wide and the second in the field of 6 digits wide. So what happens here is there will be so the first 3 digits will be printed as a number that is 3 digit wide. So 0 will be printed here, 20, and the second half of the number, this would be the tab space, not the tab exactly, but then 6 digit wide number. And then we'll have, so I guess you got the idea. We have formatted output. The more serious problem is that because we have used integer arithmetic, the Celsius temperatures are not very accurate. For instance, 0 degree Fahrenheit is actually minus 17.8 degrees Celsius and not minus 17. To get more accurate answers, we should use floating point arithmetic instead of integer. This requires some changes in the program. Here is the second version. So in the second version, what we are going to do is we are going to define Fahrenheit and Celsius as floating point numbers. And in the computation, we are going to use it as into the Fahrenheit. You need to notice that each of the number is followed by a decimal point which tells the compiler that it is a floating point number, and we have already defined Fahrenheit Celsius as a data type float. This is much the same as before, except that Fahrenheit and Celsius are declared to be float and the formula for conversion is written in a more natural way. We were unable to use the 5 by 9 in the previous version because integer division would truncate it to 0. A decimal point and a constant indicates that it is a floating point. However, so 5.0 by 9.0 is not truncated because it is the ratio of the two floating point values. If an integer arithmetic operator has integer operands, an integer operation is performed. If an arithmetic operator has one floating point operand and one integer operand, however, the integer will be converted to floating point before the operation is done. If we had written, even if we hadn't written the point 0 for 32, since the whole thing is a floating point arithmetic, it would have converted 32 automatically into 32.0. Nevertheless, writing floating point constants with explicit decimal point even when they have integral values emphasizes their floating point nature for human readers. The detailed rules for when integers are converted to floating point are in chapter 2. For now, notice that the assignment Fahrenheit equal to lower and the test. Here, the lower is still an integer, the upper is still an integer data type. Also work in the natural way. The int is converted to float before the operation is done. The printf conversion specification point also changes. Though we are going to use the formatted output, the slight modification could be the slight modification is that it is going to change. One is the percentage construction is going to tell that the number is to be replaced. Then we have the width, then we have the specification of the data type. What data type should come and fill in this number. So instead of percentage d, it is going to be replaced with this value. The printf conversion specification percentage 3.0f says that a floating point number, here var, is to be printed at least 3 characters wide with no decimal point and no fraction digits. But then, since we are going from, for Fahrenheit, we are going from 0, 20, 40, 60 to 300. We just need it to be right justified, which is handled by the 3. We don't need the decimal point, no fractional part. Hence, we are going to write it as 3.0. We need to write this 3.0. We need to specify the 0 because var is defined to be a floating point number and it would output it as 0, 0.0, 20.0 if we don't use this zero point 0 specification. For the other, for printing the Celsius, however, we need the precision. For example, 0 degree Fahrenheit is equal to minus 17.8 degrees Celsius. We need one decimal point and we also need the decimal point. So one fractional number after the decimal point. So what we need to do is we are going to still use the percentage construction. We still are going to use the the percentage 6. We are still going to describe another number that is to be printed at least 6 characters wide with one digit after the decimal point. Now the output looks more like 0, right justified, and here it would look again right justified. Width and precision may be omitted from a specification, Percentage 6f says that the number is to be at least 6 characters wide. Percentage .f specifies that 2 characters after the decimal point, but the width is not constrained. And percentage f merely says to print the number as following floating point. So if you are just going to say it as a floating point number, it is going to print var as it is. If you are going to specify the width, it is going to print with a minimum of 3 characters wide. If we are only going to say it is going to say that we need to print as a floating point 2 characters after the decimal. So this specification, this is going to say at least it should be that much wide. And yeah, among others, printf also recognizes other percentage constructions are the other construction percentages are O. This is an octal number. Hexadecimal number, which is base 16. This is base 8. Decimal and floating point are base 10. And percentage C for characters and percentage S for character string. However, if we need to print percentage itself, we need to use this percentage construct. This is more like a escape sequence where new line and to print backslash itself, we are going to use this. So in our lesson list, now we have completed section 1.2.